Welcome to this session on the use of secondary data sets with adoption data. My name is Hal Grotevant, and I look forward to talking with you for the next 30 to 40 minutes about this really important topic. So what is secondary data analysis? It's actually analysis conducted by someone other than the person or team who originally collected the data, and it's often used for a purpose not initially intended by the primary researcher. I found this little graphic that I wondered if you agreed or disagreed with. If we were sitting together in a live classroom, I'd actually get some discussion going about it, but I think it's worth looking at anyway. And the slide says, inherited data sets are like inherited toothbrushes, an act of desperation. And I'm wondering what you think of that. Why don't you give it a little thought? I think by the end of this presentation, you'll probably see or be able to infer how I would come down on this particular question. There are two goals for this presentation, and they're equally important. The first one is to discuss your role as a researcher sharing the data that you collect. And the second is to discuss your role as a researcher using data that someone else collected. So first, I want to talk about your role in sharing the data that you collect. Here you see a graphic of a beleaguered investigator with a big box of data and wanting to put it into some kind of repository so that other people can use it. This is a practice that's becoming increasingly common and increasingly required. So I do want to spend some time talking about it with you today. But before I do that, I want to back up just a little bit and talk about two reasons why this has become so important. One is the replication crisis, and the other is the reproducibility crisis. Replication, as I'm sure you know from research methods classes, is the idea that if you repeat a study or if you do it again with, say, a different sample or in a different location or with slightly different measures, that you should reach the same conclusions at the end of that study. So that's the idea of replication. It's long been an important foundation of both experimental and non-experimental empirical research. But what people have found over the years is that sometimes it's very difficult to replicate studies, and it's not always clear why they don't replicate. It's also difficult to get replications published. Sometimes people try to replicate a study and it does not replicate, and it's very difficult to get that published. And so I'm sure you're familiar with what's called the file drawer effect, that there may be a lot of studies that people tried to replicate, tried to get published, and never got published, but there was one that did reach that result that was published. So it's an important thing to think about. But aside from the replication crisis, which has been with us for a while, in the last several years, people have identified what's called the reproducibility crisis. Reproducibility is the idea that you take the same data. So you take the same data set and follow the same algorithms for analyzing the data. And if it's reproducible, that means that you come out with the same results. And believe it or not, it's been found that sometimes it's impossible to reproduce findings in given studies, even when using the same data set and the same procedures for analyzing the data. So this has raised a lot of questions about the quality of data that we're using, and has really driven people to be paying attention to data that are already out there and looking at them in a new way. As you see the caption for this graphic here that shows how close fact and fake might actually be, findings that cannot be verified when the experiments are repeated are cited 153 times more because the research is interesting, according to a 2021 UC San Diego paper. So sometimes, again, as you know, citation rates are a common metric used for measuring impact of research, but sometimes research is cited not because it has an important or positive finding, but because it's being refuted. So if you do find an article that has a very high citation rate, it's important to look beyond just the number to look at why is it being cited. The reproducibility and replication crises have propelled a movement toward what's called open science. And I want to spend just a minute with this graphic here, going around the clock, starting in the upper left with open data, to talk about the different components of open science, because as relatively new investigators, this will affect all of you if it hasn't already. Open data is the idea that data are widely accessible and available for other people to look at. Now, it's always been an important policy of journals that investigators need to keep their data for a period of typically 5 years in case other people want to challenge it or reanalyze it. But this is going even a step further. It's saying that your data not only are available if somebody challenges them, but they're available for other people to work with. So open data means wide accessibility of data, and that permits the investigation of the reproducibility of findings. The second aspect of open science, up on the top right, open source. And this means the sharing of tools and improvement of shared data cleaning, data checking, and procedures for how we work with our data. And you see here a little illustration going back and forth from the computer to the cloud, where we have data that may be stored. The third component, open methodology, refers to shared standards for data collection protocols and the development of data collection manuals, coding manuals, and so on. So if you are coding particular variables from, say, from interviews, or if you are computing scores from measures, it's important that all of those procedures be transparent and be available. Open peer review refers to the idea that there should be broader participation in the peer review process, not just by a few senior scholars at the top of the field, but including new professionals and graduate students as well, so that there's a broader kind of array of people who are giving feedback about published studies. Open access refers to accessibility to published articles. Now, most of us who are affiliated with universities don't really feel much of a crunch on this because our university libraries already subscribe to many, many journals, and we can access them electronically at no cost to us. However, the universities pay a steep cost for subscriptions to those services. And if you're not affiliated with an institution like a university, you may have to pay as an individual person in order to gain access to a full article. If you've ever searched for an article online and have found it, sometimes it'll say, oh, here's the abstract. Would you like this article? Please pay $39.95 for a download. So open access is the idea that articles should be broadly available at no charge to the public. In order to make this work financially, journals request or require that authors pay a fee upfront to publish their work in open access journals. So the author may have to pay a fee of $1,000 or $2,000, something like that, to publish an article. And then the journal commits to make that article available at no cost to anyone who wants it. There is also a mechanism already in place through the federal government in the US called PubMed Central, so that any research that is conducted with federal funds, especially from the National Institutes of Health, is automatically archived in PubMed Central and it will be available to the public at no cost. So that's already a really good model of open access. And the logic here is that the research is paid for by NIH, but the money for NIH comes from the federal government, which basically comes from taxpayers. So it's taxpayer-funded research that is being conducted. And the feeling is that the taxpayers should be able to see the results of that research and benefit from it. So open access is another really important component of open science. And then finally, open educational resources involves better training of researchers into the idea about open science, learning how it works, learning how to do it better. So this is a really important set of perspectives that I hope you will explore even further. There is a set of guidelines called the TOPS guidelines, Transparency and Openness Guidelines, from the Center for Open Science, but these guidelines are being increasingly adopted by major publishing outlets. For example, the American Psychological Association has now adopted these guidelines. And here they are. The first one is about citation, meaning that everything in an article should be correctly and fully cited, and its availability should be indicated, often by means of including a DOI, a digital object identifier, or a URL to articles, for example, that are not published, like coding manuals and things like that. There should be data transparency, meaning that in the article that you're trying to publish, you should indicate whether the raw data are available for reanalysis, and if so, where they can be accessed. The third criteria is about the analytic methods or the code or the syntax that's written to analyze the data. So if you use something like SPSS or SAS or R or M+, any of those programs, you write syntax or code in order to analyze your data. And so where is that code available for other people to look at and inspect and run? A fourth aspect is the research materials. They need to be available and described in the methods section. So for example, here's where you would talk about the availability of a coding manual that your team made up, for example, or standardized or specialized instruments that you develop. Where are the coding manuals for those? Where are the scoring instructions, and so on. Another aspect is design and analysis transparency. And APA has come up in the past several years, I think around 2018. They came forward with a set of standards for what needs to be included in publications. There's a set of these journal article reporting standards, or JARS standards. There's a set for quantitative studies, qualitative studies, and mixed method studies. And I would encourage you to familiarize yourself with those and follow them when you submit an article for publication. I can't tell you how many times I've been a reviewer for articles that have come into various journals and have read them through and have seen huge gaps in what is not, what needs to be reported but is not reported. And I often will refer authors back to these JAR standards to make sure that they include what needs to be included. Then there's the idea of study pre-registration. In other words, the idea that the design of your study and your hypotheses, if you have hypotheses, will be written down ahead of time and put somewhere where people can see them. So in other words, they won't just be something that is, on a piece of paper in your desk or something that in your head, but rather those hypotheses will be written down and set aside. And what that does is prevent people from changing their hypotheses after the fact. Let's say that you have 3 hypotheses. 2 of them are upheld and 1 of them is not. Sometimes people might omit talking about the 3rd one, or they might change the 3rd one a little bit to make it fit the data a little bit better. But that's really not the way that science works. If you're doing hypothesis testing, you form those hypotheses in advance, and then you are accountable to what your data show. So pre-registering studies is becoming increasingly important, as well as pre-registering data analysis plans. And there are archives, data archives available in the field where people can pre-register their study design and hypotheses. And there are some journals that are either strongly recommending or requiring that these things be pre-registered. So the question is then, how might this all affect you as researchers who are going to be taking your place in the field and conducting research? Most of you have already done some research, but you'll be doing more in the future. One is that potential funders, granting agencies, either federal agencies or private foundations, may require that you submit a data sharing plan and or grant open access to your data. And I put "your" in quotation marks because we tend to think of the data that we collect with any funding that we get as our data, because it was our idea, we went out and collected it, we got it, we're analyzing it, and we're writing it up. So it's kind of our data and our project. Technically, however, grants that are given to researchers do not come to individuals. They come from a federal funding agency to your institution. And the institution, then, you are the principal investigator at your institution, but the data actually are owned, in a sense, by your institution and the federal government. You don't own your data. So funders, because of the pressure really in the field from a number of places, may want you to tell them how you plan to make your data available to others. If you receive a large grant from NIH, and I think the current guideline is $500,000 in a particular year, if you have a large grant of that magnitude, you are required to make your data publicly available. But if you have a smaller grant, you are encouraged to do that. But again, this will vary by funder, and the trend in the field is to require this more and more, regardless of the level of funding. Require a data sharing plan. You may need to draft consent forms so that participants know how your data might be accessed in the future. Because let's say that you are wanting to use somebody else's data in the future to run secondary analyses. The custodian of the data might want to make sure that the initial participants gave consent for their data to be used by someone other than the initial investigator. So it's important to make sure that your consent form includes appropriate language for that. Journals may also require a specified level of transparency in order to publish there. Some of them simply require disclosure about availability. In other words, you could say in your article, the data are not publicly available, or the data are available upon request to the principal investigator. But other journals may require that the data already be archived somewhere and that you provide a link so that people can access the data. It varies by journal and it varies by discipline. But the trend is definitely moving toward more transparency in all aspects of research. So it's really important that you become informed about this and keep an eye on how this is changing in the field. But it will affect you as a researcher going forward. Now, the second topic is your role in using data that someone else collected. There are a lot of strengths in the idea of using secondary data. One grows out of the fact that there is growing acceptance and awareness that data should be shared and used to the max. It's very common to collect a lot of data in a study that you conduct, and you may use and analyze a lot of it, but there may be some measures that you never actually look at. There may be some data that are just kind of sitting there, but have great potential. And, the participants who provided the data, we're accountable to them in a certain way. Like, what have we done with the information that they entrusted to us? Have we made good use of it? And it's simply a fact that a lot of times there are data that have not been fully analyzed. So there's a general feeling that they should be used to their maximum potential. The other strengths of using secondary data are certainly considerable savings in cost and in time. Some secondary data sets are available at no cost. Some of them have a relatively modest cost, certainly a very modest cost compared to collecting original data of your own, and considerable savings in time. Sometimes the data are available for instant download, so there's really no time in acquiring them. For other data sets, you have to apply for them and be approved and so on. So they may take a little bit of time, but again, certainly not the length of time that it would take to collect your own data. There are lots of uses for secondary data. One is certainly to study hard to access populations, such as the people we care about: adopted persons, adopted parents, birth parents, children in foster care, foster parents, and so on. They are difficult to access populations. And so it's helpful to be able to access information that's already out there. Another use of secondary data is to examine feasibility of an idea or provide pilot data. So sometimes funders really, before they give you, $500,000 to do a big study or something like that, they want to have an idea that it's actually going to work, that your idea actually might yield something important before they give you all of these funds. So if you can use secondary data to make some preliminary investigations along those same lines and demonstrate, yeah, I think that this has potential. If I were to do it with a different sample or a new sample or a bigger sample or something like that, that can be very helpful. There's a kind of analysis that can be done called data harmonization, which actually takes data across several different studies that have the same measures, for example, and same types of participants. And actually what you do is basically combine data sets to have a larger data set. Now, that requires a lot of care in terms of how you do it. And it's difficult to meet all the criteria for that, because you have to have common ground at the item level of the data. But still, it is an intriguing opportunity to explore with secondary data. Another type of study that can be done is meta-analysis, which is comparing results across studies, not at the item level, but at the conclusion level and at the outcome level, at the dependent variable level. And meta-analysis means that, let's say, if you have a dozen studies that are all looking at a particular phenomenon related to adoption, like what is the effect of a particular kind of thing on a particular outcome, if you've got a dozen studies that have looked at that, then you kind of look across the studies, how many of them found what kinds of results. So that's another valuable, very valuable use of secondary data. And another use is to look for cohort effects or kind of timing or generational effects if appropriate data are available for comparison. So for example, you might want to look at the adoption trends that have occurred across a number of years when there have been big policy shifts made. So you could look at, for example, international adoption outcomes before and after the ratification of the Hague Convention, for example. So studies looking at cohort effects are possible as well. There are some challenges, however. First, it's really important to be aware of what's already been published with the data set. There's nothing more discouraging than to acquire a data set, to do a big set of analyses, to come up with your conclusions, and then to discover when you go to publish it that, oh, that had already been published with that data set by the original investigator or by somebody else. So it's really important to become familiar with your data set you're using, not only for the data, but also for the other publications that have come from that study. Another challenge is in grant writing. One of the primary criteria used in NIH funding is innovation. And so you may think, well, using secondary data is not very innovative, but actually, I think you can make a really good case for why using secondary data might be innovative. So you need to provide that justification. Another challenge is what I call buyer beware. It's really important to fully understand how the variables in the study were constructed and how the data were coded. And just a brief example, there was a study done in 2012, the New Family Structure Study by Mark Regnerus at the University of Texas at that time. And there were participants in that study who identified as gay or lesbian and who also gave information about sexual orientation, sexual behavior, and things like that. And he made some assumptions about who actually should be included in the samples of gay and lesbian participants, and basically came out with some fairly negative conclusions about psychosocial outcomes. But when people look more closely at how he did the coding and identifying of people, it was clear that the cards were kind of stacked in favor of finding negative outcomes just because of who he included in those categories and how he did that. So it led to huge critiques in the literature and all kinds of disputes, even with the funders and so on. So, you know, before you just take a data set at face value, it's really important to look at how certain variables were constructed and how the data were coded. Another thing is that you may not be fully familiar with the details of the research process that was used. How were these data cleaned, for example? Were any participants omitted from the final sample? Were any variables omitted? Were any variables recoded? It's important to know the history of the study. The data sets may be very large, complex, and challenging to link or analyze, especially longitudinal data sets with multiple waves of data, data sets with multiple measures and types of measures or sub-samples. They can be challenging to analyze, but they can also be a lot of fun. So if you enjoy working with data, I think actually it's quite a bit of fun, but it can be challenging as well. There is a risk of the data driving the research rather than the research question driving what you're doing. And that's a big thing to watch out for, is the idea of fishing for results. Because your temptation might be to say, oh, I've got this great data set. I'm going to be looking at these analyses. Oh, let's see, how are these things related? How are those related? And then you find some kind of significant results and build a study around that, rather than the way it should be, where you develop research questions from what's been done in the past, from theory, and so on, and then look at how your data are consistent with that or not. And finally, sometimes you just have to accept the fact that variables may not be constructed or coded the way that you want, and you just have to live with that, because that is all there is. Sometimes you come to a impasse and you say, this study really, the data set really does not meet my needs. I can't use this. But other times you figure out ways to make it work. And finally, a key question for us in the adoption field is how much contextual information about a child's adoption is needed. So sometimes you'll find a data set that has a question like, is this child adopted? Yes or no? And you say, great, that's good. I can work with that data set. But then you have to think, well, what else do I really need to know other than just the fact that they were adopted? For example, do you need to know at what age they were placed for adoption? Do you need to know what their experiences prior to adoption were like? Were they in an institution? Had they experienced any kind of trauma? Do you need to know about the current aspects of their adoption? Are they transracially adopted? Were they internationally adopted? All of those kinds of things. So as you know, adoption is a very complex phenomenon, and just knowing whether a child is adopted or not doesn't tell you a whole lot, really. So you need to not only look for that kind of a question in the data set, but then what else is known about the child and their adoption. A little bit about mechanics of acquiring and using secondary data. Access can vary from what's called public use, meaning that basically the data are de-identified, meaning there are no personal identifiers in the data, and the data is available somewhere for you to be able to download and use. It may be at no cost. There may be a small fee associated with it, but generally the restrictions are very few and you can just download it and go. At the other end, and there's kind of a whole spectrum of access, but at the other end are restricted use contracts. So for example, the National Longitudinal Study of Adolescent to Adult Health, or the AdHealth study, I have been working with that at different times in my career, and it requires a contract written between my institution and the home institution for the data set, which is the University of North Carolina. So I had to write a data use agreement that was forwarded through my compliance officer at our vice chancellor for research office, and they negotiated that contract with the AdHealth office at UNC. And what I had to do was make many commitments about confidentiality, about how the data would be protected, who could access the data, and so on. I can talk more about that in our Q&A discussion if you'd like. Another aspect to think about is cost. It can range from no cost up to, what I would call a relatively modest cost. I think the AdHealth, excuse me, the AdHealth data set, I believe the initial contract was either $500 or $1,000 or something like that. And that is a fee that it might be possible for you to get paid by your institution. For example, if they provide startup funds for a new faculty member, or if they provide a dissertation fellowship or something, you might be able to get costs like that paid for by your institution. You need to think about your custodianship of the data. What will you do in order to protect the data? Where will it be on your computer? Will it be stored? Will there be password protections? Will it be stored on some kind of a network, either in your lab or in your university? What are the protections there? So you really need to think through all of those issues about data protection in order to be a good steward or a good custodian of the data that you will receive. You will need to think about what kind of ethics review is needed to work with the data set. You may think that just because you can download and go, that you don't need to tell anybody about it at your institution. Generally speaking, universities want to know what you're working with, what data you're working with. It's always good to double check. I know at UMass, if you have a question about whether a particular project needs to be reviewed or not, they have a little preliminary form that asks a number of questions that you can just submit, and they'll come back to you and say, no, go right ahead, or yes, we want to review it, but it will be exempt from review by the full IRB. The IRB is the Institutional Review Board, which is the ethics committee. So always important to check with your IRB, and always worth emailing or calling them just to make sure that you're on the up and up about what you need to do. You also may need to be able to include in any publications that you submit the statement about the fact that your use of the data were reviewed and approved by your IRB. So that's another important consideration. And what else? There may be other aspects of acquiring and using secondary data that you might think about, and we can discuss them when we're meeting in person soon. I'd like to mention a major data repository called ICPSR, the Inter-University Consortium for Political and Social Research. It's at the University of Michigan, and they have been working since 1962. And as you can see, they are celebrating 60 years of groovy data. The ICPSR archive hosts over 16,000 studies comprising 5.97 million variables. 52,000 data files are downloaded per month, and it's resulted in over 102,000 publications. So that's good evidence that using secondary data can yield publishable articles, 102,000. Here is the URL for ICPSR. It's just icpsr.umich.edu. And I would encourage you to do this on your own. Go to that URL, click on Find Data, and then put a search term in there. I searched for just the word adopt, and it popped up 21,055 variables in 3,467 studies. But a warning is that not all of them are about the kind of adoption we study. Some of them might be about the adoption of technology or the adoption of agricultural practices or something like that. So, but you can do searches like adopt and child or adopt and family or various kind of Boolean searches like that that will narrow it down for you. And the word cloud on the right-hand side of this slide are the most popular search terms currently being used at ICPSR. So things like depression, crime, social media, age, race, mental health. So many of these kinds of variables are things that we care about in terms of adoption. So ICPSR is a really good resource to know about and to use. There's no charge for using ICPSR. There's no charge to individuals. Institutions pay a membership fee to ICPSR. So most major research universities are members of ICPSR, which gives them access for their faculty and students to use ICPSR data. If you find out that your institution is not a member, then you should contact your research office and find out how they might do that or how you might be able to access such data. But it's a great resource. Another one to know about is Google Dataset. So, just as with many, many things about Google, it has grown like crazy. There are over 20 million data sets available now, with more on the way every day. And they have a lot of data sets from countries outside the US. So that makes it also very interesting. ICPSR also has some data sets from outside the US, but my impression is that most of them are American data sets. But Google is much more international in scope. And to find it, just enter into a search engine, Google data set, and it will take you right there. Now, here's something that I'd like you to do before our discussion of this topic. I'd like you to use either ICPSR or Google Dataset or any other search engine that you would like to find at least one data set with what you consider to be good adoption relevant data. You know, think about what you would be looking for in a data set and find one data set to look at, and then answer these questions. And what we'll do in our discussion is allocate a little bit of time for you to talk in breakout rooms with others about the study, the data set that you found. So first, identify the study's name, investigators, and the dates and locations of data collection. Then what is the main focus of the data set? What are the major variables or constructs that would interest you and why, including things about adoption? And then what are the major features of the sample and the study design that would interest you and why? So these are the things that I would like you to do. By the way, if you haven't had time to write all of these down quickly, the PowerPoint from which this video, on which the video is based, will be available for you in Moodle. So you can actually go and just look at the PowerPoint itself and find this page. So I'm very much looking forward to our group discussion. And I also would invite you to contact me individually for any kind of consultation on this topic, and I'd be happy to talk further. And if there are any topics you'd like me to make sure we cover in our group discussion, please send that to me as well, and I'll make sure we include that and fold that into our talk. Thank you very much. I hope you're having a really good experience so far with the Summer Research Institute. We love to put this on. We love the interaction that it brings about between participants and our faculty. And I really look forward to discussing all of this further with you over the course of the Institute. Thank you very much.